Okay, question 6, the jocks and the Geordies. So we've got following tests on thousands of men. It's been established that when a steadily increasing force is applied to their nipples, the time it takes before jocks make an audible gasp of pain has a mean of 4.0 seconds. Geordies think they're harder than the jocks, and 10 of them are given the nipple test, and their times are recorded below. And we're asked to test at the 10% significance level the Geordies claim, stating 2 necessary assumptions. Okay, so this is a hypothesis testing question. So fairly straightforward, hopefully. So I think it's a good idea to state the assumptions first while you're still remembering that you're supposed to be doing that. So assumptions. Well, we've got a small sample. It doesn't say anywhere that that's a random sample, so it must be a random sample. So that's one assumption we can make. And secondly, because it's a small sample, the times must be normally distributed. Okay, fine. So now to do the test, we start with the null hypothesis, which is always that there's no change, so that is that the mean is still 4.0, and the alternate hypothesis depends on the claim. Well, we're told that the jocks think they're harder. Sorry, the Geordies think they're harder than the jocks. So we think that they think that their average time will be bigger, so greater than 4. So this is going to be a one-tail test. So if I just draw the distribution, we're looking to see whether or not we're in here. If we're in here, we will accept H0, and if we're in here, we will reject, where this is the critical value. Now we're not given the standard deviation anywhere, so this is going to be a t-test, unknown standard deviation from a small sample. It's going to be a t-test. So we're going to need a critical value of t, and obviously that will depend on the degrees of freedom. So we've got 10, a sample of 10, so the degrees of freedom is 10 minus 1, which is 9. 10% significance level, one-tailed, so 10% here, so we need to look up the 0.9 value for 9 degrees of freedom. So I'm just going to get my formula book, and here's the t distribution, and we've got 9 degrees of freedom, so we're here, and we're looking at the 10% significance level, so we're looking at the 90% value, so the critical value is here, 1.383. Good. And I'm just going to put that on there so I can see. So now we need the test value, and the test value is given by this formula: sample mean minus the alleged mean divided by S over root n. So we need the sample mean and the sample standard deviation, so I need to get my calculator up. Go to the stat menu and put this data in. I'm just going to get rid of that value, that list there. So I've got the data, so we've got 4.3, 4.5, 4.2, 4.1, 4.1 again, 3.9, 3.7, 3.8, 4.3 and 4.2. 10 values. Calculate the single variable statistics, and we can see that the mean is 4.1. I'm just going to plug that straight into the formula. Divided by S 0.24698. Divided by the square root of 10. And that's the calculation for the test value. I'm just going to do that calculation. So 4.11 minus 4.0 divided by 0.24698 divided by the square root of 10. And I get a value of 1.408, and that is the t-test. And I can see that that's greater than the critical value, so I'm going to say 1.408 is greater than 1.383. So I'm in the reject region, so I'm going to reject H0 and say that there is significant evidence that, I just need to go back to the question, remind myself. So the Geordies think they're harder, and that's what we've established that is true, that the Geordies are harder than the jocks. Excellent. Good. Stating two necessary assumptions, well, we've done that at the top. Okay, good. Part B. Another study using a different method definitively concludes that jocks and Geordies are equally hard. Explain what type of error, if any, you've made, given the probability of making this type of error. Well, we have rejected H0 when it's true. So I'm going to say that's the explanation. We have rejected H0 when it's true, and H0 being true and rejecting it is what we call a type 1 error. And I could have guessed that because the probability of making a type 1 error is knowable, whereas the probability of making a type 2 error is not knowable. The probability of a type 1 error is the significance lever, which in this case is 10%. And that's that question finished.